Hey Algebra 1, thanks for tuning in. This is our last section of notes for 6.1. We're talking about scientific notation today. It is fairly easy. You do have 13 things to write down, but it should go by pretty quick, so let's go and get started. The first thing we want to know is how to write stuff in standard form, and that just means they have no scientific notation, there's no decimals. But if the exponent is negative, you'll move stuff to the left, or move the decimal point to the left, and if the exponent is positive, you move the decimal point to the right. So this is just two important things you're going to write down for number 1. And the exponent is going to tell you how many times to move your decimal. So what we'll do is go ahead and pause the video here so you can write down number 1, and then click play to see how it's done. So these are just two examples. One has a negative, the other one has a positive exponent. What you do first is you start with your decimal given to you, 3.22. And then you figure out what is your exponent telling you to do. This one is negative 4, so we're going to move 4 spaces to the left because it is negative. So I'm going to start here at my current decimal and just scoot 1, 2, 3, and 4. All these empty spots are going to be filled up with zeros. So I'm going to have 0.000322. Okay. For letter B, same type of deal. I start with 7.9, except this time my exponent is a positive 5. So I'm going to scoot that 5 places to the right. 1, 2, 3, 4, 5. And then fill the empty spots with zeros. So my answer is 79 with 4 zeros at the end, or 790,000. Okay. So pretty easy and simple. Let's go ahead and get you to try these two on your own, and then once you're done, click play to check your work. So let's go ahead and pause here now. Okay, for number 2 we have the number 6. So I'm going to start with that, and then there are 7 times we're going to move the decimal in the right direction, or the positive direction. The decimal in the number 6 is at the end, so I'm just going to create my own decimal and then scoot it 1, 2, 3, 4, 5, 6, 7. Or just a 6 with 7 zeros behind it makes 60 million. For number 3 though, I have 9.9 and I'm moving 5 spaces to the left. 1, 2, 3, 4, 5. I'm going to fill up 4 empty zeros, so I'll have 0.000099 as my answer. Okay. These again are two examples, so let's go ahead and try these. Let's pause the video here, try it, and then once you're done, click play. Alright, so for number 4, how we're going to write in standard form is we start with the number 1.56 and move it 7 times to the right. 1, 2, 3, 4, 5, 6, 7. Filling my empty spots with zeros, so I have a 156 with 5 zeros at the end, or 15,600,000. For number 5, I'm starting with 6.3 and moving 5 spaces to the left. 1, 2, 3, 4, 5. So I have 0.000063, or 4 zeros between the decimal and the 6. The next part we're going to talk about is how to write numbers in scientific notation. If the number is greater than or equal to 10, you're using a positive exponent to show how many times you use your decimal point. So if I have 8,600, my decimal would need to go between the 8 and the 6, and that would be 1, 2, 3 spaces. So that would be a positive 3, so 8.6 times 10 to the 3 would be my answer. But if I have a number between 0 and 1, I would still find out where my decimal goes between the 2 and the 4, but this time I had to move it backwards to the left 1, 2, 3 times, which means my exponent would be a negative 3. Let's go ahead and take time now to pause and write down number 6, and once you're done, click play so you can see how it's done. Alright, so here's an example. We're looking at this big number. It's 1,650,000,000. And we want to write it in scientific notation. A helpful way why we write scientific notation is because we don't have to write all these zeros. I do know that my decimal needs to go between the 1 and the 6 because my number needs to be between 1 and 10 but still less than 10. So my decimal will be 1.65 times 10 to the something power. So I'm just going to count what my exponent should be. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my decimal point needed to be moved over 9 times, so my exponent would be a positive 9. So my answer for this example would be 1.65 times 10 to the 9th. Here's another example, except now my decimal is smaller. I do need to get my decimal between the 2 and the 6 to make 2.68. So 2.68 would be my decimal that I'm going to use, times 10, but I need to figure out my exponent. This exponent is going to be 1, 2, 3, 4, 5, 6 places to the left. So my final answer would be 2.68 times 10 to the negative 6. Okay, so after seeing those examples, here are a few that you're going to get to try, and then we'll talk about how to use operations with these. So let's go ahead and pause the video, write your answers in scientific notation, and then click play when you're ready to check. Alright, for number 7, your decimal needs to be between the 3 and the 4 to make 3.4. So we will have 3.4 times 10, but let's find out what our exponent is. 1, 2, 3, 4. That's 10 to the negative 4th power because you had to move back to the left. For number 8, my decimal needed to be 6.75, and then my exponent needed to be 1, 2, 3, 4, 5, 6, a positive 6. Number 9, my decimal needed to be after the 7, so I could either write 7 or 7.0, both mean the same thing. Let's figure out how much my exponent should be. 1, 2, 3, 4, 5, 6, 7, 8. So that'd be a negative 8th power because I had to go back to the left to write my new decimal point. And then the last one on this page, number 10, I have a decimal that needs to go between the 1 and the 2 to make 1.25. And then my exponent would be 1, 2, 3, 4, 5. So 1.2 times 25 times 10 to the 5th power. The last thing we're going to look at is how to evaluate these. And your example is to write your answer in scientific notation. You might want to think of your property of exponent rules. You could, in fact, write these out in expanded form. So I'm going to give you a chance to do that now. You're going to basically add both scientific notations. So let's go ahead and pause the video here, see if you can try number 11, and then we'll go into some explanation here in a moment. Alright, so what you could have done is just started with 3.1 and done your 4 movements to the right. 1, 2, 3, 4. So that's 31,000 plus 2.3 with also 4 movements to the right. 1, 2, 3, 4, which is also 23,000. And when you add those together, you get 54,000. But you don't want to keep your answer as a standard form. You want it back in scientific notation. So your final answer should be 5.4 times 10 to the 4th power. Okay. Notice that both of these things have something in common. All we did was add the 3.1 and the 2.3 to get 5.4, and we kept the 10.4 the same because 3.1 time plus 2.3 is still less than 10. It's 5.4, so we can keep our exponent the same. So maybe just keep that in mind for next time. 12, a little bit different because you're multiplying these. So let's go ahead and try. Maybe again use product. See if you can remember how to use product of powers rule here. And then once you're done, click play to check your work. So let's go ahead and pause here now. Okay, 2 ways you could have done this. I'm going to show you the longer version first, and then we'll talk about the shorter version and how that makes sense with the longer one. We have 7.5 times 10 to the 7. So that is the number 75 with 6 zeros behind it. Okay, and then we're going to times that by 4 times 10 to the 7th power. That's a 4 with 7 zeros behind that. Okay, or 40 million. What we're going to try to figure out is after we multiply these, what I like to do first is just focus on kind of do an old school math trick. Do 75 times 4. Okay, that's going to give you 300, and then you're going to add all your zeros back to it. Okay, so there are 1, 2, 3, 4, 5, 6 zeros here, and another 1, 2, 3, 4, 5, 6, 7 zeros here. If I write 300 and then add my other 6, 1, 2, 3, 4, 5, 6, and then my other 7, 1, 2, 3, 4, 5, 6, 7, that's a big number. but I would want to write it as 3 times 10, and then count your decimal movements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so this will be your final answer. Here's one other way that you can look at it. You could have just done 7.5 times 4. 7.5 times 4 is equal to 30. And then you would add your exponents together. So 10 to the 14th power. The only thing that's wrong with this is you cannot have 30 times 10 to the 14th power. That's too big. We would need to change that to a 3. But because we had to go over one extra number, that means we also had to add 1 to the 14. So that's how we could also get 3 times 10 to the 15th power. Either way works. This way, I feel like you can always double check your answer. This way is a little bit shorter. You just have to be super confident in what you're doing. The last one in number 13 is a division problem. It says write your answer in scientific notation. Use the exponent properties to help you. So again, keep in mind your negative exponent rules. I maybe would deal with that first and then get going with your problem. So let's go ahead and pause for 13, try it, and then once you're done, click play. All right, so what we can do here is I went ahead and wrote everything on the bottom to get rid of that negative exponent. So I still had 6 times 10 to the 7th, and then times 1.5 times 10 to the positive 8 on the bottom as well. Again, two things you can do. You could either write these out all at once. I'm going to go ahead and do that real quick. So there's my 6 times 10 to the 7th. That is a 6 with 7 zeros behind that. And then 1.5 times 10 to the 8th is a 15 with 7 zeros behind that. You could go ahead and multiply this all the way. I would do 6 times 15, which I know is 90, and then add in the extra zeros. So that's 90 with 14 zeros behind that. All over the number 1. Or I could just rewrite this as scientific notation, which would be 1 over 9 times 10 to the 15th power. Again, you could have done it this way originally, or you could have multiplied 6 times 1.5. 6 times 1.5 is still 9, so that's included in the less than 10 idea, and then added your exponents. 10 and 10 are the same base, so you can just add your exponents there, so 10 to the 15th power. Same thing, just a whole different way. Again, be confident in your answer. Sorry for that interruption of the bell. That is all we had for today for scientific notation. Thanks so much for tuning in, and we'll catch you next time.